Hi students, good morning to all of you. So in this class we are going to discuss vertical axis wind turbines, VAWTs. Already we have seen we have two different types of wind turbines, that is horizontal axis wind turbine HAWT, and next one will be vertical axis wind turbine. Already we have seen the horizontal axis wind turbine, and the next one will be vertical axis wind turbine. Okay, vertical axis wind turbines are in the development stage. They are only in the development stage, and many models are undergoing field trials. Okay, the main attraction of vertical axis wind turbines are, okay. So the first one will be it can accept wind from any direction. Okay, the main advantage of the vertical axis wind turbines are it can accept wind from any direction. Okay, so it may be east to north, okay, like that, in any direction. Okay, east to south, okay, south to north to south, south to north, or east to west, west to east, in any direction it will accept the wind. It can able to produce the okay, kinetic energy. Okay, the kinetic energy can able to extract and produce the mechanical energy. In any direction if the wind flows, okay, it can able to extract the kinetic energy. That is the main advantage. Yes. Okay, so as it is possible, air control mechanism is not required. Okay, air control mechanism, always the head is moved in the direction of, or nacelle is moved in the direction of a wind. Okay, if it accepts wind from any direction, no need of air control mechanism. No need of air control mechanism. Okay, the gearbox, generator, etc. are located at the ground level. Okay, before in a horizontal axis wind turbine, all the generator, gearbox, switchgear mechanism, everything will be placed on the top of a tower. Okay, so on the top of the tower, so that you need a strong tower construction. Whereas here all these components will be placed on the ground only. Placed on the ground, well, no need of a strong or a heavy tower in this vertical axis wind turbines. Vertical axis wind turbine. Next, the design and installation is simple. Okay, all we are placing on the ground on all components, the design becomes simple. And okay, the inspection and maintenance also becomes, if they are kept at the top, okay, the regular maintenance is required. As we are placing all the components on the ground, regular maintenance is not required. Okay, it also reduces the overall cost. As you did not require strong construction of the tower, the overall cost will be automatically decreases. Okay, this will be the diagram. This will be the diagram of vertical axis wind turbine. This will be the diagram of vertical axis wind turbine. Now you can observe here. So we have a foundation. Above that you will have the generator. Beside generator we have switchgear equipment and gearbox mechanism, brakes. Okay, to stop the so generation for maintenance purpose you will use the brakes. And between the two bearings, egg-beater type of construction is there, like an egg-beater type of construction will be used. Okay, so where it will take wind from any direction and can able to extract the kinetic energy. So and the shaft, on the same shaft all the generator and everything will be placed. Once this shaft is rotated, automatically generator will produce the electrical output. The produced electrical output will be given to the grid. Okay, this is called as this type of construction can be called as egg-beater type of construction. Egg-beater type of construction that you can say egg-beater construction. Okay, so generator, bearings. The bearings, generator, gearbox, brakes, like that some supporting structure we have used. Okay, these are called as the gear ropes to provide the balanced rotation. To provide the balanced rotation, gear ropes will be used. These are all the different components that we will clearly see one by one now. We will clearly see one by one now. Okay, the construction details of vertical axis wind turbine is as shown in the figure we have already seen. The details of main components are as follows: tower or rotor shaft. Okay, the tower is a hollow vertical rotor shaft which rotates freely about the vertical axis between the top and bottom bearings. Between the top and bottom bearings. Okay. Now you can observe here. This will be the tower, which can be freely rotate, and it is a hollow structure. It is a hollow structure. Okay, that is it. It is connected between the two bearings. It is installed above the supporting structure, just above the supporting structure. It is installed. All the equipments are constructed on the ground only. Okay, you can observe. So we are not keeping any component on the top of a tower. All the components are placed on the ground only. All the components are placed on the ground only. No need of strong construction of tower. Okay, because all components we are placing on the ground, no need of, okay, so strong construction of the tower. The upper part of the tower is supported by guy ropes. Upper part of the tower is supported by the guy ropes. The height of the tower of a large turbine is around 10 centimeters. The height of the tower of a large turbine is around 10 centimeters. Okay, that is about tower structure. Next, coming to the blades. It has 2 or 3 curved blades shaped like an egg beater, just like a shape of an egg. The blades have an airfoil type of construction. Okay, airfoil type of construction. Blades have airfoil type of construction. The pitch of the blades cannot be changed. Okay, here the thing will be the pitch of the blades is fixed as it is taking. Okay, so as it is taking wind from any direction, okay, the pitch also may not be controlled. The diameter of the rotor is less than that of the tower height. The diameter of the rotor is less than that of the tower height. Next. No need of strong support structure. The last one will be support structure. The support structure is provided at the ground to support the weight of the rotor. The support structure is provided at the ground to support the weight of the rotor. Okay. Next, gearbox, generator, electrical switchgear and controls are housed within the structure. All these things will be housed within this, okay, structure. Yeah. All these things will be placed here in the supporting structure. Next, coming to different types of vertical axis rotors of vertical axis wind turbines. Different types of rotors of vertical axis wind turbines. Various types of rotors for vertical axis wind turbines are as shown in following figure. We will have cup type rotor, Savanius rotor. 2 cylinders are oppositely connected to a common shaft. Which will be called as a Savanius rotor. Next one will be Darius rotor. Rotors will be just now we have shown the Darius rotor only. Darius rotor which will receive, okay, wind from any direction. Next, Musgrove rotor. And final will be Evans rotor. Like that, different types of rotors are available. Cup type rotor, Savanius rotor, Darius rotor, and we have Musgrove rotor and Evans rotor. Okay, mostly we will go with the Darius type of rotor. Coming to okay, the first one, cup type rotor. Okay, 3 or 4 cup type structure or cup type or rotor. Okay, coming to this is the simplest rotor structure. Okay, there are 3 or 4 cups are connected to the central tower. As they are rotating, central tower also continuously rotated on the, okay, simply can say the vertical shaft or rotor. Okay, the cups are connected with the wind blow. If the cups are rotating, shaft also rotated such that, okay, the kinetic energy of wind will be converted into the, okay, mechanical energy or rotation of a shaft. The same shaft will be connected to the generator. The generator will produce electrical energy. So the cup structures you can observe here. We have a concave nature and convex nature. Okay. If the force is on the convex nature, then more force will be applied. Okay, more force will be applied on the convex nature when compared to the concave nature. When compared with the convex nature, you can observe. However, these types of rotors, cannot produce bulk amount of electric. As cups are there, very small amount of force they can able to receive, and very small amount of electrical power they can able to produce. Here, the cups will be rotated, in a linear way with respect to the wind. So most of the cases, this type of cup type rotors will be used to measure the wind speed. This cup type of rotors are also called as cup anemometer. Cup anemometer that you can observe here. Cup anemometer that you can observe here. Cup anemometer. And next, Savanius rotor. The Savanius are S-type rotor. The Savanius or S-type rotor consists of two half cylinders. Attached to the vertical axis, and facing in opposite directions to form rotor. It has high starting torque, low speed and low efficiency. These are used for low power applications. A high starting torque, particularly make it useful to water pumping applications. You can observe here two half cylinders. If oppositely connected, you will have the Savanius type of rotor. So whenever wind is blowing continuously, they will be rotated such that the shaft will be rotated. This will be used for high starting and low speed and low efficiency. Mostly it will be used for water pumping applications. Savanius rotor, combination of two opposite cylinders which will continuously rotated with respect to the weight such that mechanical energy will be produced. And the next one will be Darius type of rotor. So in this Darius type of rotor is mainly used in a large scale for power generation. Even what we have discussed now. Savanius water lifting applications mainly it will be used, whereas Darius type of rotor is mainly used for power generation applications. So better than that of S-type rotor. It is better power. It is having better power coefficient when comparing with the S-type rotor. One of the drawback of this type of rotor will be it is not a self-starting. You have to use a generator or motor to start it. As the pitch of the blade cannot be changed, the rotor frequency and output power cannot be controlled. We cannot be able to generally in a wind turbines, the output power and the frequency will be controlled by changing the pitch. Here, as two blades are fixedly placed, you cannot be able to change the pitch such that you cannot be able to change the output power and the frequency. Next, coming to Musgrove type of rotor, and in these two are Musgrove type of rotors. The main drawback in before case Darius type of rotor will pitch you cannot able to control. Here the pitch of the blades will be controlled. It is also called as a H-shaped rotor. Here the pitch can be controlled by folding the rotor wings, which are as shown in the figure. Thereby we can able to control the frequency and output power. Here this folding, you can able to fold according to the wind condition. You can able to fold such that like this you can control the pitch such that output power and frequency you can able to control. And the last one will be Evans rotor. In the Evans rotor, the rotor blades can be completely twisted. Here you can only fold, but here completely the rotor blades can be rotated. So such that more control of frequency and power can be obtained in the case of a Evans rotor. You can observe here. So these are the blades which can be completely 360 degrees, which can be rotated with respect to the wind. Okay, continuously they can be, pitch can be controlled such that more control on power and frequency you can able to uptime. Thank you very much. We will see in the next class.